You are welcome once again to the Mathematics Solution Center. Today we are going to be looking at the derivation of trigonometry identities. We are going to derive all the trigonometry identities under this topic. But please don't forget to subscribe to this YouTube channel, share it, like it, and then click on the notification button so that you will know when we upload the next video. Thanks. If I have a right angle triangle, let the hypotenuse be represented with letter C. Here is letter A, and here is letter B. And the angle here, let it be angle theta. Using our SOHCAHTOA, so simply means opposite over hypotenuse. But take note, when we are talking about opposite, it means the side that is opposite to the given angle, or the angle we are referring to. That means our opposite is A as far as this theta is concerned, while the adjacent is B. And the hypotenuse is always the longest side of a right angle triangle. Sin theta is equal to opposite A over hypotenuse. Cos theta is equal to, my adjacent is B over C. Y tan theta is equal to opposite over adjacent. Let's evaluate sin theta divided by cos theta. What is our sin theta? A over C divided by our cos theta is B over C. This is the same thing as A over C times C over B. C and C will cancel. Therefore, I have my sin theta over cos theta equal to A over B. This A over B is the same thing as the value of tan. Therefore, the conclusion is that tan theta is equal to sin theta over cos theta. This is an identity. Although all those sign value of a thing, they are also identity. But there are some other trigonometry ratios I can define. Like 1. Okay, let's talk about sec theta. Sec theta, don't forget, always take note of the third letter in all these sec theta, cosec theta, and cot theta. The third letter is the beginning of another trigonometry ratio. Like C is the beginning of cos. Therefore, sec theta is equal to 1 over cos theta. And cosec theta, this is what will make you to remember all this relationship more easier. So the third letter is S, which stands for what? Sine. That means cosec theta is equal to 1 over sine theta. Then cot theta. Cot theta. Cot theta is going to be, the third letter is T for tan, 1 over tan theta. If tan theta is equal to sine theta over cos theta, therefore, cot theta will be equal to, since cot theta is reciprocal of tan theta, cot theta will be equal to cos theta over sine theta. Now let's draw another triangle. We have this. This is our C. This is A, and this is B. We keep our angle theta. Using Pythagoras theorem, the relationship between the sides of a right angle triangle is given by Pythagoras theorem. And Pythagoras theorem states that the square of the hypotenuse is equal to the sum of the square of the other two sides. Please take note of that statement, so that you will not write b square is equal to c square plus a square, which is wrong. But it is always the square of the hypotenuse. The square of the hypotenuse, c square, is equal to sum of the square of the other two sides. That is our Pythagoras theorem. Now let's divide this expression through by c square. I have c squared over c squared over c squared. C squared divided by c squared is 1. Then equal to, this is a over c into a squared plus b over c squared. Therefore, I have 1. If you look at the diagram, or from our first set of sine and cosine value, sine theta is equal to opposite over hypotenuse, which is a over c. Therefore, my a over c is sine theta. We call it, since it is squared, we call it sine squared theta. Plus, my b over c is actually cos theta, and it is squared. We call it cos squared theta. From this, we've gotten an identity, which is what? Sine square theta plus cos square theta is equal to 1. We are going to divide this expression through by cos square theta. Therefore, we have sine square theta over cos square theta. Then plus cos square theta over cos square theta is equal to 1 over cos square theta. When you divide an expression throughout with the same term, you have not altered the expression. Therefore, I have sine square theta over cos square theta is actually sine over cos theta, sine theta over cos theta, then all squared. Then plus cos square theta divided by cos square theta, the answer is 1, which is equal to 1 over cos square theta is actually 1 over cos theta squared. Now sine theta over cos theta, don't forget we said earlier that it is what? Tan theta, but it is squared, it becomes tan squared theta plus 1 is equal to 1 over cos theta is actually sec theta. So sec squared theta. This is another identity. This is an identity, but we can rearrange it to get another identity by making any of its components the subject of the formula. From this, I can say sec squared theta minus tan squared theta is equal to 1. These are sub-identity under the main one. And we can as well say that tan squared theta is equal to sec squared theta minus 1. The same thing, we can decide to divide. At the same time, we can divide sine squared theta plus cos squared theta is equal to 1 throughout by sine squared theta. This time around, we are going to divide this equation throughout by sine squared theta. Therefore, we have sine squared theta over sine squared theta again, then over sine squared theta. Then sine squared theta will cancel sine squared theta, then we have 1 plus cos squared theta over sine squared theta, that is cot squared theta, and then is equal to 1 over sine squared theta is cosec squared theta. So this is an identity. We can get some other sub-identities from this identity by a rearrangement. Therefore, cot squared theta is equal to cosec squared theta minus 1. Cosec squared theta minus cot squared theta is equal to 1. These are the other sub-identities that we can derive from this identity. Thank you very much. In our next video, we are going to see how we can apply different types of identities to solve problems. Thanks for watching. Please don't forget to subscribe, like, and share it. And don't forget to put on the notification button so that you'll be notified when our next video will be uploaded. Thanks. God bless.